Today we're going to integrate this ugly looking integral that has fractions in the exponents. Let's get into it. First thing that we're going to do working with this is you'll notice that it just looks awful with those fractions up there. So let's do a u substitution and try and get rid of some of this. We're going to start with x to the 1/4 is equal to u, and you'll see why in just a second. The first thing that we want to do is let's see what regular x is. If we take both sides to the 4th power, that is going to get rid of the 1/4 on the left-hand side, and we're going to end up with u to the 4th power on the right-hand side. Now, if we take our derivative, dx, we get 4 times u cubed du. All right, now this all looks great and dandy until you realize, oh my gosh, we still have an x to the 1/2. What do we do with that? So we're going to take our original x to the 4th and we're going to modify that just a little bit. We're going to take our x to the 1/4 and we are going to square both sides. So we're going to get u squared. So this is going to give us x to the 1/2 is u squared. All right, so now we have all of our substitutions in here. And on the top, our x to the 1/4 ends up being a u. In our denominator, we get 1 plus u squared. And instead of our dx, we end up with 4 times u cubed du. Let's rewrite that one more time. So I'm going to go to our next page and we will smush everything on the numerator together. We have 4 copies of u, 1 plus u squared du. And let's do one more thing. That 4 is a constant. Let's pull that out to the front. U to the 4th over 1 plus u squared du. All right, this is the second part that ends up really, I don't know what to say. It's just nasty. We have this u to the 4th on the numerator that's just a little bit out of place. Now, you'll notice that the 1 plus u squared on the denominator, if you recall, 1 over 1 plus u squared, the antiderivative of that is tangent inverse of u. So we know how to deal with that part. We just don't know what had to do with that u to the 4th. And this is where we have to be a little bit creative. And I'm not sure entirely how much you are going to love this. So this is going to be u to the 4th. And let's think about it this way. I'm going to do this in a couple bits. Let's say we can add and subtract 1 and we really haven't changed it. We're actually going to make the top messier in order to be getting our antiderivative out of it. So we can break things up a little bit. U to the 4th, we're going to add, subtract a little bit more here. U to the 4th, and we're going to add u squared, and then we're going to subtract u squared, minus 1 plus 1. Now this bit here, plus and minus u squared, that actually is going to look really nice, and we're going to have to go to the next page. When it reduces to, we can factor it as u squared minus 1, u squared plus 1. And we have a plus 1 left over. You can factor that out to double check and make sure that it works. You'll notice as we go through this, right, u squared times a plus 1, u squared times the minus 1, that's where we had that plus and minus 1 u squared coming in. We have the minus 1, and then we have the u to the 4th there. So yes, it looks uglier. However, this is going to make our lives a lot better. Now, we are going to just do a bunch of algebra and we'll be able to get through this. And the reason why I say that is because you'll notice now our numerator has a u squared plus 1 and our denominator has a 1 plus u squared. So what we're going to do is we're going to break this up into 2 different fractions. So I'm going to put a big bracket here. We have u squared minus 1, u squared plus 1, all over 1 plus u squared, du, plus the integral of 1 over 1 plus u squared du, and our square bracket. So we're ripping it apart that way, in particular because then we can cancel out that 1 plus u squared in the first integral of the two that we're working with. So now what we have, if we rewrite this, is going to be 4 square bracket integral u squared minus 1 du plus the integral of 1 over 1 plus u squared du. All right, now we can actually take our antiderivative of each of these integrals separately because we know exactly what's going on. For the first one, we add 1 to our power, we divide by our new power, add 1 to our power, and then for the second one, this is, as we said before, tan inverse of u, and we're going to do a plus c on there, on the back side. So distribute this out. This is 4/3 u cubed minus 4u plus tan inverse of u plus c. And if we recall, u is equal to x to the 1/4. So we're going to pop that back in everywhere we see our u because we started with x's, so we have to end with x's, which means we end up with 4/3 u to the 3/4 minus 4x to the 1/4 plus 4 tan inverse of x to the 1/4 plus a constant. And there is the solution to that really tricky integral. Thank you so much for listening.